particle P of mass 2 kg. So this is particle P, this is of mass 2 kg, is traveling with an initial velocity of u meters per second, whereas particle Q is at rest, which is of 4 kg, so its initial velocity is 0. So momentum before collision is 2u plus 4 into 0, which is 2u. The same particle after collision are moving in the opposite directions. So Q will move here, P will move here. The masses will remain unchanged, 4 kg and 2 kg respectively. The final velocity of P is 1/3 of the velocity of Q. So if velocity of Q is V, then velocity of P is 1/3 of V. So momentum after collision is 2 upon 3V plus minus 2 upon 3V plus 4V. Why minus? Because it is moving in the P is moving in the opposite direction. So this turns out to be 10 upon 3V. This is 10 upon 3V. So we know that the momentum before collision and momentum after collision are same. So 2u is equal to 10 upon 3v is v is equals to 3 upon 5u. V is 3 upon 5u, which is the velocity of Q. Velocity of P is 1/3 of velocity of Q. 1 upon 3 into 3 upon 5u, that is 1 upon 5u, and it is proved. Okay, so let's look at question number 7. This is truck A, which has a mass of 600 kg. This is truck B, which has a mass of m kg. They both are moving in opposite directions. The initial speed of A is 4 and initial speed of B will be -2 because it is traveling in the opposite direction. So momentum before collision is 4 into 600 plus m into -2. After collision, the trucks are joined together. It's a case of coulisse, if you remember. So AB will become together. So this will become 600 plus m, and velocity is 0.5. So this becomes 0.5, 600 plus m, and they both are equal. 2400 minus 2m is 300 plus 0.5 m. So 2400 minus 300, it's 0.5 plus 2m. 2100 is 2.5 m. So the value of m is 2100 divided by 2.5, that is 840 kg. 840 kg. In question number 12, the question states that each of the two wagons has an unloaded mass of 1200 kg. One of the wagons carries a load of mass m kg, other wagon is unloaded. The wagons are moving towards each other on the same rails, each with a speed of 3 meters per second when they collide. So this is wagon A, this is wagon B. A and B are traveling towards each other. A has a mass of 1200 and carries a load of m kg. The other is empty, it is unloaded, so it only has a mass of 1200 kg. They both are traveling with an initial velocity of 3 meters per second, and immediately after collision the loaded wagon is at rest and the speed of unloaded wagon is 5 meters per second. So immediately after collision, the loaded wagon is at rest. So A will be at rest, 1200 plus m, final velocity is 0, and B is 1200 but it is traveling with a velocity of 5 meters per second. So we need to find the value of m. This becomes 3 into 1200 plus m plus 3 into 1200, 0 plus 5 into 1200. So this is 3600 plus 3m plus 3600 is 6000. 3m is 6000. Alright, since this is traveling in the opposite direction, this is minus 3. So this is minus 3600 and this becomes 3m. This cancels off. 3m is 6000, m is 2000. Always remember that when the direction is opposite, the sign will be minus 3. Please be careful about that. 3 uniform spheres L, M and N have masses 0.8, 0.6 and 0.7 kg respectively. The spheres are moving in a straight line on a smooth horizontal table with M between L and N. The sphere L is moving towards M with a speed of 4 meters per second, and the spheres M and N are moving towards L with a speed of 2 and 0.5 meters per second respectively. L collides with M. As a result of collision, the direction of motion of M is reversed and its speed remains 2 meters per second. Find the speed of L after collision. So before collision, L has a momentum of 0.8 into 4, M has a momentum of 0.6 into minus 2, 3.2 minus 1.2, the result is 2. And after collision, L is 0.8. The speed of L is unknown, so 0.8 v. M, which was moving in a negative direction, will now be moving in a positive direction. The speed remains same. So this is 0.6 into 2, that is 1.2. So this is 1.2 plus 0.8 v. So the result is 2 is equals to 1.2 plus 0.8 v. 0.8 v is 2 minus 1.2. 0.8 v is 0.8. V is 1 meters per second. So this was the first part. The second part is M now or then collides with N. Find the total momentum of M and N in the direction of M's motion before this collision takes place, and deduce the direction of motion of N as result as of this collision. So before collision, this time M and N are colliding after the first collision. So before the second collision, M is 0.6 moving in the positive direction, and N is 0.7 moving in the negative direction. So find the total momentum. This is 1.2 and this is 0.7 into 0.5 is 0.35 negative. So the total momentum is 0.85 before the second collision. Given that M is rest immediately after this collision, find the speed of N immediately after this collision. So the next part is After second collision, M comes to immediate rest. Find the speed of n after this collision. N is 0.75 v. 0.85 is before collision, 0.7 v is after collision. V is 0.85 divided by 0.7, which is 1.21. This is the correct answer. A particle of mass 0.5 kg is projected with speed 6 meters per second on a smooth horizontal surface towards stationary particle q of mass m kg. After the collision, particles collide. P has a speed of v meters per second in its original direction and q has a speed of 1 meters per second more than p. Okay, so this is 0.5, this is m, this is 6 initially, and this is rest initially. Final, this becomes v and q becomes 1 plus v. So m into 0 plus 0.5 into 6 is equals to m into 1 plus v plus 0.5 v. So this becomes 0 plus 3 is m plus mv plus 0.5 v. 3 minus m is v m plus 0.5, and I think that is what we need to show. V m plus 0.5 is minus m plus 3. So this is shown. This was 16 part 1. In 16 part 2, you are told that q and p are now projected towards each other. So this is q, this is p, this is m, this is 0.5. Initial velocity is 4. Initial velocity is minus 6 because it is in the opposite direction. Immediately after the collision, q is v meters per second. So this is v meters per second with its direction of motion unchanged. It is still in the positive direction. Q and P are now projected towards each other with initial velocity of 4, and this initial velocity is 2. This initial velocity is 2. Immediately after collision, Q is v meters per second, which is in the direction of the motion unchanged, and P has speed 1 meters per second more than Q. P has speed 1 meters per second more than Q, and now this will be in opposite direction, because obviously after collision the direction of Q is being unchanged, but the direction of P will be changed. Find another relationship between M and V in the form this. So 4m plus 0.5 into minus 2 is initial momentum. mv plus 0.5 1 plus v is the final momentum. 4m minus 1 is mv plus 0.5 plus 0.5 v. 4m minus 1 minus 0.5 vm plus 0.5. So v m plus 0.5 is 4m minus 1.5. So where a and b are constant, so a is 4 and b is minus 1.5. The next part is, by solving these two equations simultaneously, show that m is 0.9. So you have to solve this equation and you have to solve this equation, these two equations simultaneously. So this will be v, m plus 0.5 is minus m plus 3, v, m plus 0.5, 4m minus 1.5. Let's subtract the two equations. This will become minus, this will become plus, this will cancel off, this becomes minus 5m plus 4.5 is 0, minus 5m minus 4.5, m is 0.9. That we needed to show off, and hence find the value of v. So in either of the equations, insert find v, m plus 0.5 minus m plus 3, v is 0.9 plus 0.5 minus 0.9 plus 3, v 1.4, 3 minus 0.9 is 2.1, v is 1.5 meters per second. Question 17. A railway wagon A of mass 2400 kg and moving with a speed of 5 meters per second collides with railway wagon B, which has mass of 3600 and is moving towards A with a speed of 3 meters per second. So this is A, this is B, 2400 kg and 3600 kg, initial velocity 5, initial velocity minus 3 because it is moving in the opposite direction. Immediately after collision, the speed of A and B are equal. They both are equal, but the question says, given that the two wagons are moving in the same direction after collision, find their common speed. State which wagon has changed its direction of motion. So since they both are traveling in the same direction, I will consider both velocities as v. Whosever's direction would have changed will depend on the sign of v. So let's check out. This is 2400 into 5 before collision, 3600 into minus 3 before collision is 2400 v plus 3600 v. So 2400 into 5 is 12,000 minus 3600 into 3 is 10800. 2400 plus 3600 is 6000 v. So 12,000 minus 10800 is 1200 is 6000 v. V is positive. 1200 divided by 6000, that is 0.2. So it indicates that it is positive, which means that the sign of B has changed, so the direction of B has changed. In the next part of the question, given instead that A and B are moving with equal speeds in opposite direction after the collision, calculate the speed of wagons, the change in the momentum of A as a result of collision. So if they are after the collision, they are traveling in the opposite direction, it means that the initial momentum will remain same, that is 2400 into 5 plus 3600 into minus 3, and after the collision they are moving in the opposite directions, so it means that direction of A has changed negatively and direction of B has changed positively. So this becomes 1200 is 1200 V. V is 1 meters per second. And the change of momentum as a result of A. So as a result of a change in momentum is 2400 into minus 1 minus 2400 into 5. So this is minus 2400 minus 2400 into 5, that is 12,000. So change in momentum is negative 14,400. Question number 18 states that the two particles P and Q have masses 0.7 kg and 0.3 kg respectively. P and Q are simultaneously projected towards each other in the same straight line on a horizontal surface with initial speed of 4 meters per second and 1 meters per second respectively. Before P and Q collides, the horizontal force acting on each particle is friction, and each particle's decelerates at 0.4 meters per second square. The particle coalesce when they collide. Given that P and Q collide 2 seconds after projection, calculate the speed of each particle immediately before collision and the speed of the combined particles immediately after collision. So since the particles are decelerating, let's find out the initial speeds first. Initial speed is 4 for P. Initial speed is 1 for Q, minus 1 for Q. Deceleration is minus 0.4. Time is 2 seconds. So V is equals to U plus 80. V is 4 minus 0.4 into 2. 4 minus 0.8, that is 3.2 meters per second. V is U plus 80. U is minus 1. A is minus 0.4 into 2. But when we are considering the velocity, we will consider only the positive signs at the moment, because irrespective of the direction, the speed is slowing down. So 1 into minus 0.8, V is 0.2 meters per second. So these are the velocities before collision. Velocities before collision. I hope I am clear to all of you. Now you are told that after collision the particles coalesce and the speed of the combined particle immediately after collision is to be found. So momentum before collision, mass is 0.7, velocity is 3.2 plus 0.3, velocity is minus 0.2, and hence the momentum before collision is 0.7 into 3.2, 2.24 plus 0.3 into 0.2 minus 0.06 is 2.18. This is the momentum before collision. Momentum after collision is 0.7 plus 0.3 because they have coalesced is V. So you need to find the speed of the combined particle immediately after collision. So this is 0, this is 1V. So 1V is equals to 2.18. So velocity after collision is 2.18 meters per second. Then the next part of the question is given instead that P and Q collide 3 seconds after projection. Sketch on a single diagram the velocity time graphs for the two particles between 0 and 3 meters per second. So in this case, initial velocity is 4 and 1. Acceleration is minus 0.4. Time is 2 instead 3 seconds. V is u plus 80. V is u plus 80. V is 4 minus 0.4 into 3. 4 minus 1.2. V is 2.8 meters per second. And V is 1 minus 0.4 into 3. V is 1 minus 1.2. V is 0.2 meters per second negative. So the velocity time graph of the two particles will be from 4 meters per second. This particle is going to a speed of 2.8 meters per second in a matter of 3 seconds. And this particle is going from 1 meters per second to minus 0.2 meters per second in the matter of 3 seconds. Calculate the distance between the two particles at the instant when they are projected. In order to calculate the distance between the two particles when they are projected, we need to find, we have the initial velocity of both particles 4 and 1. We have deceleration minus 0.4. We have time as 3 and we need to find S in both the cases. S is equals to ut plus half at square in both the cases. S is u, that is 4, t, that is 3, plus half minus 0.43 square, which is 10.2 meters, and S is equals to 1 into 3 plus half minus 0.43 square. So S is equals to 3 plus 9 times of is 1.2 and hence it is 11.4 meters. Then there is question 19. The question states that P and Q are is a line of the greatest slope of length 4 meters on a smooth plane inclined at 30 degrees to the horizontal. Particles A and B of mass 0.15 kg and 0.5 kg respectively move along PQ with A below B. The particles are both moving upwards, A with 8 meters per second, B with 2 meters per second. When they collide at the midpoint of PQ, particle A is instantaneously at rest after collision. Show that B does not reach Q in subsequent motion. Since the plane is smooth, we have no worries of frictional force. All we need is initial velocity is 8 meters per second of A and B's initial velocity is 2 meters per second. They collide halfway, which means that after traveling a distance of 2 meters, they collide. After collision, Q comes to rest, but B does not comes to rest. Okay. So before collision, A is 0.15 kg into 8 plus B is 0.5 kg into 2. After collision, this comes to rest, but B keeps on moving. So this turns out to be 0.15 into 8, that is 1.2 plus 1 is 0 plus 0.5 V. 2.2 divided by 0.5 is V. V is equals to 2.2 divided by 0.5, that is 4.4 meters per second. So this is the velocity of V after the collision. Now we need to prove that in the subsequent motion B does not reach Q. So now the initial velocity of B is 4.4. Final velocity will be 0. And since it's smooth plane, acceleration will be g sine theta. G sine theta will be 10. Since it's moving up, it is minus g sine theta. Minus 10 sine theta is 30 degrees. Sine 30 is half. So minus 5 meters per second square. And we need to find S. If S is 2 or greater than 2, it has reached Q. If S will be less than 2, it has not reached Q. So let's check out. V square minus U square is 2AS. 0 square minus 4.4 square is 2 into minus 5S. 4.4 square is 19.36 upon minus 20. S is 0.968, which is less than 2 meters. Why 2 meters? Because the whole slope is of 4 meters. The collision takes place at midpoint. After collision, it needs to cover up 2 meters to reach the top, but it is falling short, and this is 0.968. So it has not reached Q. So it has not reached Q. The second part of the question is, find the time interval between the instant of A's arrival at P and the instant of B's arrival at P. So after collision, A comes to instantaneously rest. Initial velocity becomes 0. It is falling down the slope, so acceleration is g sine theta, that is 10 sine 30, which is 5. S is 2 meters per second. So I need to find the time at which A reaches P. So S is equals to ut plus half at square. S is 2 meters, u is 0, time I don't know, plus half A is 5 t square. 2 is 5 upon 2 t square. T square is 4 upon 5. T is under root of 4 upon 5. So it takes 0.89 seconds to reach the bottom for particle A. Find the time interval between the instant of A's arrival at P and the instant of B's arrival at P. For B will first go up and then it will come down. So we need to find the time for which B is going up. B is going up. In the previous part, we calculated that when B is going up, its initial velocity is 4.4. Its final velocity is 0. Its acceleration is minus 5. So V is equal to U plus 80. 0, 4.4 minus 5t. Time that V takes to go up is 4.4 divided by 5, that is 0.88 seconds. Then to come down, coming down. When it is coming down, its initial velocity is 0. Its acceleration is 5 because it is coming down. G sine theta is 5. The distance that it has traveled up is the initial 2 and then 0.968. So it has to come down 2.968. And we need to find the time. So once again, S is equals to ut plus half at square. S is 2.968. U is 0. T is something that I need to find. Plus half A is 5. T is something that I need to find. So 2.968 is 5 upon 2 t square. T square is 2.968 into 2 divided by 5 is 1.1872. So T is equals to under root of answer, that is 1.0896. So total time of going up and coming down is 0.88 plus 1.0896 is 1.96 or 1.97. This is 1.97. 1.97 minus 0.89. 1.97 is the total time for B to come down. 0.89 was the total time for A to come down. So the final answer is 1.08 seconds.